Okay, yep, it turns out that there was an error in the notes, so let me go ahead and pull the corrected notes up. And we'll continue where we left off in part A. Sorry about that. So remember we were talking about this event 2, which is going to be the case where we have leakage from the landfill by during light rain, but when we have a failure essentially in both of the barriers, including poor compaction of the clay layer and then also holes in the geomembrane. And so basically that's going to involve the intersection of poor compaction, which is the W complement, intersected with holes, and then intersected with a moderate or light rain, which is the E complement, conditioned on heavy rainfall or a light rainfall. And so that's the union. And that, of course, is our possibility space. And so we just, because it's normal when we have something conditioned on the possibility space to just write the event itself without the condition. And okay, so then basically we're interested in the probability of this event. So we take the probability of it. And again, we recognize that construction is statistically independent of climate or rainfall. And so we can express this as the product of the probability of the construction times the probability of light rain. And we bring that down. See, I got the light rain this time. Now we can express this probability of intersection W complement H using the product rule. So W complement condition on H times the probability of H. And then furthermore, we can express this conditional probability as 1 minus the probability of a well-compacted clay layer conditioned on holes. And remember, we know what this is. It's 0.6. In fact, we know what everything is. We know 0.6 for this conditional statement. We know the probability of holes, which is 0.3. And then we can deduce the probability of light rain as the complement of the probability of heavy rain. And the probability of heavy rain is 20%. And so the probability of light rain is going to be 0.8. So when we multiply all those out, we get 0.096. So about 9.6%. So that's interesting, actually. The probability of event 2 is 9.6%, which is a bit higher than the, I think it was 5.6. Just kind of go back quickly to see what event 1 was. Yeah, 5.6 for event 1. And that's in part due to the fact that, we have light rain a lot more often than we have heavy rain. Okay, the next question that we're asked is, are the events W and H mutually exclusive, and are they statistically independent? Okay, we probably can guess that W and H are not mutually exclusive because you can have one or both of them occur. It's not like if one occurs, the other one can't, but we'll demonstrate that in a second. And then in terms of them being statistically independent, well, we know they're not statistically independent because we talked about how the fact that if there are holes in the geomembrane, that's going to lower the probability of a well-compacted clay. But we can do the actual mathematical tests. So for the test for mutual exclusivity, I mean, there's a couple different ones, but one of them is, look, if W and H are mutually exclusive, then the probability of W given H would be 0, but in fact, we know from the problem statement it's 0.6. So we conclude that W and H are not mutually exclusive. And then for statistical independence, we know that if W and H were statistically independent, then the probability of W conditioned on H would just simply be the probability of W, which we know from the problem statement is 0.9. And 0.9 is not equal to 0.6, which was the value of the conditional probability given in the problem statement. And so therefore, we know that these two events, W and H, are not statistically independent, which is another way of saying they are statistically dependent. Next set of questions are events 1 and 2 mutually exclusive, and are they collectively exhaustive? So this is a bit different than the question about W and H, right? Because W and H are different events than events 1 and 2. Events 1 and 2 are created from W and H, but they are different events. And we can kind of look at events 1 and 2 and maybe make a guess about whether they would be mutually exclusive. I think they are mutually exclusive just looking at it, because event 1 requires heavy rainfall, whereas event 2 requires ordinary or light rainfall. Since those two events are mutually exclusive, conditioned on rainfall of one form or another, that implies that event 1 and 2 are going to be mutually exclusive. And we'll see that mathematically in a second. Collectively exhaustive, it's really hard to say. We're going to have to actually try to figure that out. Okay, let's do a test for mutual exclusivity. One of the things we know is that if event 1 and 2 are mutually exclusive, then if we intersect them, we should get the null. And so we take event 1, remember, which we figured out was this W complement union H intersect E, and we intersect it with event 2, which is W complement H complement E. And we can do some rearranging by the commutative rule. So one of the things I want to do is bring E and E complement together, because I know that the intersection of E and E complement is the null, and the intersection of the null with anything else is the null. So in fact, yes, this intersection of E1 and E2 equals the null set, which implies that events 1 and 2 are mutually exclusive. Test for collectively exhaustive. For that, we're actually, probably the easiest thing to do is just to map out in a Venn diagram what's going on. So we have our sample space, which is represented by this rectangle. And remember, within that sample space, we basically have rain of one form or another. And we've divided that rain into two types of rain: light rain, or might call it moderate rain, versus heavy rain. So that's our sample space. And then within that sample space, we have the event where the clay layer is well compacted. And then we also have an event where the geotextile has holes in it, and those are potentially overlapping. And so we are asked to determine, basically, what we want to do is we want to map out in this space where E1 and E2 fall and determine if they cover the entire space. And wow, that's really interesting. Turns out that in Google Slides, my patterns are not showing up from PowerPoint, but I think we can make this work. Hopefully we can. So basically, let's think about it. Let's use our imagination, since the patterns are not appearing correctly. So if we look at event 1, so we know that's event 1, we can bring E inside the parentheses here. So we get the union of W complement time, or intersect E, union with H intersect E. So let's consider each of those independently. So W complement, what is that? Basically, it's everything outside of the W circle here. So it's the entire sample space outside of that W circle. And then we intersect it with heavy rain. And so basically, that's going to be only the regions which are outside of the circle and also in the heavy rain region. And what is that going to be? It's going to be basically this white region here. And also it's going to be, boy, it's really unfortunate. This is confusing. I'm going to stop the video and try to correct this problem too.